So, hello students, this is what we are going to learn today. Today's topic is variation that we will be learning in 8th grade here. So, variation is a part which we will be finding this where x and y are the two variables. We'll consider two x and y two variables. And these two variables will be writing, these two variables will be written in a form as x equals ky. What is the concept of variation here? Variations means what? If x is increasing, suppose, then y should also increase. And if x is decreasing, the y should also decrease. So both are working hand to hand. How we have hand to hand. If one is going up, other will be up. One is down, other is down. So those are related to that other. So in this is the basic concept. Now in this, if you'll consider there are two types. One variation works with two types of shifts actually. So if you'll go in this way, if one is one, you can say one, I will display this one and two. One will be direct variation called as a direct variation. And if we'll work on the other way, what we'll say this, suppose this is a direct. Second one is indirect. We will call it as indirect here. Okay. So indirect variation and direct variation are the two methods. Direct means for just what I explained. One is going up, other is up. One is down, other is down. Both are working directly over here. But if the step observes in this way, if one is going up, as usual, if you will say that x is up and y is going down. If x is down, y is up, then we'll call it as indirect variation. One is increasing, other decreasing, and then we'll call, and one is decreasing, other is increasing. It is called indirect variation. That is inversely proportional. What we call in a form of science or physics, what we call this is directly proportional, this is inversely proportional. So this is direct variation, this is indirect variation. Now let's go for this direct variation. We'll work this for a direct. This we will be working as a direct variation here. Okay, this is a direct form. Why we'll call this as a direct form? That's the reason is that the x is increasing, y is also increasing. So it is indicated by notation. How we are noting that it is noted by this way. This alpha symbol is that x is directly proportional to y or x is directly variated with y. And we'll be converting that x equals ky, where k is the constant. And the equation becomes x equals ky or x upon y is equal to k. Is the equation form of direct variation, where k is constant of variation. We will call k as a constant of variation here. Now, for example, how we are examples are there. One, if area of circle and r, a equals r square. Now, how we got this? We know the formula. A is equal to pi r square, right? So, if pi is a constant, that is 3.14. Excuse me. Pi is constant, 3.14 here, or 22 upon 7, whatever. So, A is this we will consider this as constant. Area is directly proportional to radius, a is square of the radius. Area is directly proportional to square of radius. Similarly, one more example from the science physics side. If P varies directly with the depth, as pressure increases, depth increases, or as depth increases, pressure increases. Both way. So we'll say that pressure of liquid is directly proportional to depth of liquid. This we will call as direct proportion. One of the another example of direct variation. This is the another example of this of what? This will be another example of direct variation. Okay, direct variation. Understanding the concept of direct variation? Okay, we'll go ahead with some. Assume one thing now. If x varies directly as y, x is equal to 5, y is equal to 30. Find constant of variation. That is the question given here. That means if x is directly proportional to y here. So we'll be using the formula here. How we are going to solve here? Just wait. What? So x equals 5, y equals 30, x equals ky. This is our formula. So when x will be 5, k we don't know. We have to find this k here. This is what we want to find. K multiplied by 30. K will be 5 divided by 30. So what will the value of k? K will be 1 upon 6. This is one of the examples where we'll be finding the k over here. Right? Now let's go for one more example with where y varies directly as square root of x. If you'll consider it this way. So we find the constant of variation. Suppose now in this case if y varies directly as square root of x. This is what is expected. Square root of x here. So according to formula, if we have y is equal to k into square root of x. We have to find k in this here. This is what we are learning, constant of variation. So if x, let's plug in the values. How values are plugged in? If you will observe this one, uh, this value of x is plugged over here, and this value, second value, this value 24 is plugged over here, right? So as a result, what will happen? This is over here and this will be plugging over here and you'll be getting the result here. So how this will be? Let's begin. So if I'm plus substituting the values there, y equals 24 is equal to a root of 16 there. So taking the square roots, we can get 24 as it is just in here. K times 4, square root of 16, that will be, that what we'll be getting, that is 4. So 4k is equal to 24. K will be equal to 6. So this is what we got, the constant of values. We will call this as constant K. Value for the constant here. Just remember, we are getting K as 6. This is how we found the constant. What with the 2x? Okay, we are going to continue with the indirect variation in our next video. Please, if you like this video, please like and subscribe and continue to watch the whole videos. Okay, thank you. So let's begin with this part here. Just remember, we'll be working total remuneration paid to the laborers here. That is laborers and employed to harvest soybean. What we are harvesting, they are harvesting soybean is in direct variation. Now here the part is we are working with a direct variation. Remember, we are working with a direct variation with number of labor. Now, in this case, we are not going to find the constant of remuneration. We will be finding the values. If remuneration of 4 laborers, that is rupees, 1000 rupees, find the remuneration of 17 laborers. That is what the answer. What is their question they are asking here? Now, let's begin with this part. So, if you consider this, in this case, let's go. Uh, the first part, how you will be working, just observe this. If C is directly, first part we'll be having here, we'll be taking in this way, we'll consider C. Let assume C is directly proportional to L. That is, the cost is directly proportional to the labor, right? So this will be your first part. Now, what will be the equation formed? The equation form? Equation formed will be C is equal to KL here. What is the equation we are forming? Equation formed is C is equal to KL. So can you get? So I should observe this C equals KL will be the equation form, where K will be your constant here. Understand? So K will be a constant here. C is equal to K, K with the constant. Now first part. What is the first part? What we are going to do? We will let us assume this one 1000. Let's give for what is the given valuation rupees 1000. 1000 will be equal to K times 4. So this is K times 4 there. So these are the two values what we are working here. So if you consider this K as constant of this one constant of variation, sorry, multiplied by 4 times. From that you will first calculate, and like last time, K will be equal to 1000 divided by 4. That will be K will be equal to 250. That is what you will be getting it. Now, if you'll assume, we'll use this value of K, in this equation here. Getting it? We'll be finding this value of K in the form of equation. How we'll be getting here? Equation. Okay. So just plugging the value of K over here, and the given values are now new values. New values 17 laborers. What is the value given? 17 laborers here. So if you consider this 17 laborers value, we'll plug in L. For L, we'll be plugging this 17 here. L will be equal to 17. Yeah? So as a result, we'll be getting this final values here. So L is equal to 17. So 250 times. Let's change the color for more compatibility. Let's go. So with this color, let's go. So 250 multiplied by 70. That is the value. So finally, you'll get. I'm not changing the currencies. Dollars and so 215 times 17. 4250. Let's calculate this one. So we'll be getting here of 250. So you can go 25 to 17 there, 425, and you can add up 0 for the this one. So 4250. So this is what the value you are getting in this case, 4250. So that is the cost. That is the cost in rupees here. So C will be 4250 rupees. That is the what the valuation for the 17 remuneration for the 17 laborers that you will get here. Okay, thank you.